Hi, welcome. I'm Fedor, and today I'm going to show you the Mo-sys StarTracker system and how to set it up and how to get started. So let's see what you get in the box. So in the box, we get the Mo-sys processor unit, we get the touchscreen monitor, Mo-sys sensor, a wireless keyboard with some tools and a wireless dongle, mounting bracket, the magic arm, umbilical cable, HDMI with the touchscreen capability for the monitor, the lens encoder cables, and power supply to connect the processor unit. And we also get the sticker markers for setting up the star map. So with the Mo-sys processor unit, it's basically the CPU for the system where we connect everything together to make it work. Here we get the touchscreen monitor, which we can use to control the processor and the system, either with the wireless keyboard or the touch screen. So here we have the Mo-sys StarTracker sensor, where you have the safety cap on. When not in use, you want to have it protected. When in use, you always want to take it off. And here we have a camera with the sensors that will register your sticker markers in the ceiling or floor, depending on your setup. Here in the back, we have the on-off switch, and where you will connect the umbilical cable to the processor unit. And under it, you have the mounting system to mount the sensor, depending on your setup, onto the camera or under. Then we have the mounting bracket, depending on your camera system, and your magic arm to connect the touchscreen monitor with your processor unit or to your camera system. We have the umbilical cable, which will connect the processor unit to the sensor. And we have the HDMI and touchscreen USB cable to connect the touchscreen monitor to the processor. Here we have the lens encoder cable, depending on are you using zoom lenses or only prime lenses. So you can use only one gear or two gears. Here we have at the end the power supply that will give AC to everything. Lastly, after the power supply, we have the stickers, which you get also in the kit. And this is the first part of setting up the Mo-sys system. The stickers are reflective, which get picked up by the Mo-sys sensor. And that's basically how it works, the whole tracking system. And when setting up your star map, you want to first measure your studio ceiling height. And depending on the ceiling height, you want to order the sticker size. In our scenario, we have a studio ceiling height of 5 meters, and that's why we're using stickers of 5 centimeter size. And you want to put them apart each other of 1/10 of your ceiling height. So we have a ceiling height of 5 meters, so we want to keep them apart of 50 centimeters. Most important, when putting your stickers onto your ceiling, you want to have them clearly visible and as randomly as possible, and you want to have them on different heights so they will get better picked up by the Mo-sys sensor, and you get a better parallax effect. And you want to avoid putting them on anything movable like cables, lights, and you want to put them on fixed beams or pipes or the ceiling itself. Now when you set up your stars onto your ceiling, we start with assembling the Mo-sys StarTracker. And in this stage, we don't need the camera. All we need is to put everything together, what we get in the kit, so we can map the stars and create our map in the system. So we start off with getting a look into the Mo-sys processor unit, where in the backside we will connect the USBs and the HDMI to the monitor. Onto the front side, we will connect the umbilical cable, which will connect to the sensor. And here we will connect the AC, and we will start by mounting the magical arm to the monitor itself, so we can have the monitor above the processor unit. Now I'm mounting the touchscreen monitor onto the magical arm, so I can have a setup that I can have the touchscreen monitor above the processor unit, so we can use it and hold it in our arms while walking around the studio while we are mapping the stars, and you want to have it well tight. When you've mounted your monitor with the magical arm to your processor unit, we will take the HDMI cable. We will connect one end to the monitor itself. Then we will take the other end and we will mount it into the processor unit to get touchscreen capabilities to the monitor itself. Now we take the power cable, connect it to the monitor, and we take the other end and connect it to the processor unit monitor power. You want to watch out for that red dot matches to the red dot because there's only one way in and one way out. Now when we have the cable set up for the monitor, we want to adjust the magic arm so we have the monitor above the processor unit. So we will tighten the magical arm. So when we walk around the studio while mapping the stars, we can hold it in one hand. Right? Now comes the fun part. We take the umbilical cable and we connect one end into the processor unit, and the second end goes into the sensor itself. And lastly, we take the power supply and we connect it to the processor unit. And you want to be gentle with the cable. It only goes one way in because you don't want to use any force to pull it because you might break it. So this is ready. Now we can go to the studio and set the rest of the mapping. Now we take the Mo-sys StarTracker and we place it on the floor in the middle of your star map of your studio. Now we take off the safety cap of the sensor and we plug in the processor unit and it should automatically start. Just wait 30 to 60 seconds and the Mo-sys StarTracker software will boot itself. Now after the Mo-sys system has started, we get the graphical user interface that will look like this. It says no map loaded because we don't have any map that we have created. But we can see that it's picking up the tracking markers on our ceiling with the infrared sensor. So the touchscreen we can use simply with our finger. And here we see menus on the side, which are by default locked. To unlock them, on the right corner side, we have like a square, which we press, and after it's selected, we can unlock one of the menus. If we want to unlock all the menus, we can press and hold for 2 seconds and release. All the menus will be unlocked. In the right upper corner, we can see another square we can press to get more information about the Mo-sys sensor. When we've started the system, we've unlocked the menus. Now we can go into the main menu and press Wizards tab, and we have the introduction that will tell us more about how to unlock and how to use the graphical user interface. To create a new map, we go under Main, Wizards, New Map, and we will build a new map. Yes. We will name our map. In this case, we can just call it map. OK. Just follow the on-screen instructions to put in the ceiling height in meters, in which case you want to put in the average height of your ceiling, in which case we have a 4.5 meters height. As we can see, here is the sensor exposure that we can play with and the radius of the detection of the stickers we have on the ceiling. They're white colored. We want to have a magenta red circle around them so we know the sensor is detecting them. We can play with the exposure and the radius. We can start with making the radius bigger. As I make the radius bigger, we can see that the sensor is detecting more sticker markers on the ceiling. When you've put in the ceiling height, sensor exposure, and your radius, we can still see some of the stickers are not getting detected by the sensor. We can go into stars, and we can see here our minimum radius and size margin. We can put the size margin a little bit bigger, and this is in centimeters. And we can touch anywhere around the touchscreen to go full screen mode, and we can see most or all stickers are getting detected by the sensor. After we have set up the minimum radius and the size margin, and our stars are being detected in the ceiling, we go back to the main and we go for the next step. And it says press spacebar to start setting up the grid for our star map. Now we take a measuring tape, and it tells us to measure 50 centimeters and move the sensor in a straight line by 50 centimeters. It will tell you how many centimeters to move your sensor depending on your ceiling height. By this time, you don't want to be moving your sensor too much, and you don't want to be occluding the sensor. You want to move only the sensor slowly and steadily in a straight line. When you've done, press spacebar. Now, the Mo-sys StarTracker system has created a red-green grid that represents a real-life 1 square meter in your ceiling. If you see that your grid is too small or too big, redo the last step. You might have moved the sensor too wobbly or too fast or too slow. And you can also measure 1 square meter in your ceiling to check if it matches. So now we go for the next step. We press next, and we see it's telling us optical good. If something is wrong, it will tell us optical fail, and we're going to have to go a step backwards and redo it. For the next stage, we will take the processor unit and the monitor in one hand and the sensor in the other hand, and we will be mapping all the stars in your studio. Now you can touch outside the menu to get into the full screen mode so you can see the stars. You will be walking around the studio in random forms, and you want to be moving the sensor up and down so all the stars get detected. While moving around the studio, it's important to have eyes on the points in the left upper corner. We have 115 points, which is the amount of stars the sensor has saved. And then we have a /KF, which is the keyframe number. And the keyframe number needs to be 1/3 of the amount of stars that have been so far mapped in our map. To making the keyframe number higher, you want to be moving the sensor up and down while walking around the studio. In the right upper corner, we can see 60 to 70 number, which tells us the amount of stars are visible in that moment. In every moment, you want to have at least 14 stars that are visible. A really good number is around 30. More is better. Now we have a friend with us that will be holding the power supply and cable, and we will walk around the studio with slow movements and going up and down with the sensor. Very important. So we get the keyframe number up, and you want to have an eye on optical good. If you get an optical fail information, you want to go back a step where you had optical good and redo it. All this repetition will give us a higher keyframe number, which will be better for the parallax effect and occlusion. It's looking good. Right now we have 220 stars and a keyframe of 75. We will continue mapping until we have come to the number that we have put the stickers on the ceiling, and we have a third of that number in keyframe. After mapping, I have got optical fail, which tells me I need to go a step backwards and redo the last step of movement until I get optical good. I will know when I'm done with the mapping is when I have around averagely the same amount of stars mapped as I've put the stickers onto the ceiling. I know that I've put 250 stickers and we have mapped 250 points, and we have a keyframe number of 100, which is more than enough for a really good map. Let's go to the next step. Now when we're done with mapping the stars, we can go next, and when we're satisfied with the map, we can finish and go to the next auto alignment procedure. When you've done the mapping, there's another process you need to do, is auto align, but we can do that after we have disassembled and mounted the processor and the sensor onto a camera setup and on a tripod. And we can see in the mapping, our map, which is called map, has no asterisks. It means it is saved. Otherwise, you can save it. But now, after the map is saved, it's safely to shut down, which we do by going into the main, general, and here we have restart and shut down. And we can safely shut down the system and disassemble it. Now, after you've shut down the system, we will put the safety cap onto the sensor, and we can disassemble the Mo-sys StarTracker, and we're going to attach it to our camera and mount it onto a tripod. I will detach the monitor. Put the cables on the side. I will disconnect the umbilical cable. Put the sensor on the side. Now I'm going to detach the power supply. The processor unit itself, we already mounted our tripod plate under it. And now we want to attach our camera setup onto the processor unit. We do that by unscrewing the 6 Allen screws. Now we take the plate from the processor unit and we will mount it under the camera unit. Depending on your setup, you can mount it different ways. And in our scenario, we have a quick release system. And what's also important, you want to have the umbilical cable side on the back side of the camera. Now we tighten the plate from the processor unit to our quick release plate from our camera unit. And we mount it back onto the processor using the provided screws. When the processor unit is ready, we can mount it onto the tripod. Now we can move on mounting the camera unit. Next step after mounting the camera onto the processor unit, we will take the sensor itself. We can detach the cable while we mount our bracket, depending of what kind of setup you have. You can use one of the provided brackets compatible with many different cinema cameras like the Blackmagic or Arri cameras. In our case, we're going to put on rods, and we will use another different mounting system. After I've mounted the bracket under the sensor, it's pretty firm. Now I will mount it on top of the camera. It's best if you have the sensor as closer to the sensor of the camera, and you want to have it above the sensor camera, which is usually the symbol on sides of cinema cameras. After we've mounted the sensor on top of the camera, we also want to have the connectors pointing backwards. And now we can start with mounting the monitor, and after it, connecting the cables. Okay, the monitor is pretty firm. I'm satisfied, and now I will move on connecting the cables back again. I'll connect the HDMI monitor cable. The USB for the touch screen. I will take the power cable for the monitor. Goes on the side of the monitor. Now we take the umbilical cable and we connect the umbilical cable into the processor unit. Needs to be all the way in, and then into the sensor itself. That's good. Now we can take off the cap. We can connect the power adapter into the unit itself. Now when we've connected everything and the software is started, we can move our tripod camera setup into the studio. When you start the system, you might get an I/O error, which tells you it can't detect the sensor, or the sensor is not getting any AC. So you might have to restart the system, and you need to maybe detach the umbilical cable, attach it again, and restart it. So we're going to do it right now by detaching the umbilical cable and attaching it back again. We will unlock the menus by holding for 2 seconds in the right low corner. We will go into the menu and restart. Wait for 10 to 30 seconds and the system will restart itself. Now we have optical good. As we can see, the sensor works. Let's move on to the next step. After the system is restarted, it's always locked. So we can unlock all the menus, go into menu, wizards, and now we can continue where we left off by going to the auto line. we can follow the instructions after we have mounted the sensor on top of our camera. We want to measure the offset, the TP right, down, and forward offset from the Mo-sys sensor compared to the sensor of the camera. Now we take our measuring tape and we will measure the distance from the Mo-sys sensor, which is located right here on the edge in the middle. And we want to measure it in meters from the sensor of the camera. Now we're going to measure the TP down, which is going downwards, and we're going to input that into the system. For me, it is 16 centimeters, and I will put in TP down 16 centimeters, but it needs to be put in as a meter value, which will put in 0.16. We don't have a TP right. We can have it 0 because the sensor itself is right above, aligned with the camera sensor. Now we will measure the TP forward. The TP forward will be positive if we're measuring forward, but because we're measuring backwards, this camera sensor is back from the Mo-sys sensor. Now we're going to measure the TP forward from the Mo-sys to the camera sensor. We're going to take something to align it with from the camera sensor so I can measure it correctly. And since the TP forward is going backwards, we need to input a negative value, because the TP forward, if it's going forward, we would put the positive value. So we can put minus 0.02 in meters, which is, we have 2 centimeters. And now this is our TP forward offset from the Mo-sys sensor to the camera sensor. And we can move on to the next step. So now in this next step, we want to take a minimum of 3 points and put them in your studio. You want to have them in the middle of your studio. And so we can tell the origin point for the Mo-sys, so it also knows the relation to real world. Where is it moving inside your studio? So now we can move on setting up those 3 points. So now I have prepared some marking tape with the right angle. I have a laser pointer to measure the distances and a measuring tape. I will measure the ceiling height, and I will take the average ceiling height closest to meters. I will round it up, which we have 5 meters. And we're going to first point. We will measure that. And I have the average height of 5 meters. We will take first marker, which will mark the origin point for our system. And you want to have it roughly around in the middle of your studio. And you want to make an X and Y axis with other tapes. And you want to have a right angle between the X and Y axes. A distance between those points, you want to have at least minimum the half of your ceiling height. In which case, in our scenario is, we have a ceiling height of 5 meters. So we're going to put the distance 2.5 meters between the origin point to the X-axis point and to the Y-axis point. We have taken a piece of styrofoam just so we can get a right angle for setting up our coordinate system. We have a distance of 2.5 meters. We will also use a laser pointer to be exact. Now I will take another tape and I will mark the X-axis point. We can move on to the y-axis. We have a right angle towards our y-axis. We will measure the same distance of 2.5 meters from the origin point, and we will place our y-axis coordinate. So now when we have measured the coordinates, in our case it's 2.5 meters, which is the half of our average ceiling height. Now after putting our 3-point setup in our studio, we will go for the next step for setting up the auto aligner. Here we need to put in reference points coordinates in meters for our 3 points. You can have a maximum of 6 points. We have 3 points, and the first point is our origin, which is 0, 0, 0. We can keep it in that. If you're using one of the provided auto aligner kits that you can get from Mo-sys, which you can get spheres for your coordinates, then they're 2 centimeters high in height, so you're going to have to put in the height. But in our case, because we're using tapes directly onto the floor, we're going to leave it on 0. In our point 2, for our x-axis, here we're going to put in 2.5 meters, because that's the distance from our origin point. And the y-axis and height we will keep on 0. On point 3, for our y-axis, x is 0 and y is 2.5 meters, because that's the distance from the origin point. And height we will also keep on 0. Now we can continue on to the next step. Here in this step, we will start with the observation phase, which is collecting observation points from our reference points through the camera. In this step, we will use the camera's center point, and we will look towards our origin point, and we will add that point into the auto aligner by just pressing add 1. You can always delete last if you make a mistake, and you will continue doing that for x-axis point and your y-axis point for your, depending how many points you have. We have 3 points, for instance, so we will be adding point 1 for 2 and 3. After we add those points, we will move the camera with the tripod on a different position and redo that process. So this is my origin point that I'm trying to align the center point of my sensor camera. You want to use a zoom lens in this case, so you can zoom as much as possible and focus on that point. In this stage, it doesn't matter what lens do we use. We're zooming fully into our origin point, and you want to focus to the point, and you want to align it as best as possible. In this stage, it's also convenient to have a good monitor connected to the camera. Now when I'm happy with my point, I will just add it into the system. And it also tells us add observation of point 1. And now we can continue to the next point. Now I'm happy with the placement, and I will add the second point. Okay, now we'll continue to the next part, adding the third point. I'm happy, and I will add the third point. On the side, we can see APTD letters, which is for angle, position, translation, and distance. We want to get rid of those letters by moving the camera around the studio and looking at the markers on the ground and adding them again in the same row as we did just now. Besides the official wizard instructions that we're using, we can always go to the offset menu, where you can also see the offset values we've put in from before, and we can go to the auto aligner tab, and we can see that we've already input one observation for each point, the origin, the x, and the y, and we can still see the APTD letters, which we want to get rid of by moving the camera around in the studio and looking again and doing observations to the tracking points on the floor. Now I've moved the camera 1 meter away, and I will redo the same observations to the marker points on the floor. After I've moved to a new position in the studio and I'm looking at the origin point, fully zoomed in and focused, I will add that point again. Okay, after I put in the third observation for the third point, we can also go and check in the offset tab in the autoliner that we have lost the letters A and P. So now we have only T and D left for all three positions. So we're on a good track, and we want to continue with more observations around the studio to get rid of all letters. Then we know we're doing good. Now we've done 7 observations and we got rid of the letters. So we've done that part and we're ready for the next step. Now we can see we got rid of the letters, which are usually here on the side. Or we can go to the offset tab and we can see for the 3 points, no more letters. And we've done 7 observations. We can go back and go to the next step. Now, after we pressed next, it has done the calibration part, and it's told us it succeeded, and we've got an error margin of 0.3, which is really good. You always want to be under 0.5, which is the best. You always want to be under 2. Everything close to 2 or above is bad, so you want to redo the calibration by redoing the auto alignment process. Now we can apply the calibration. Now to verify, we need to put in the reference height number of the origin, and we already know it's 0 because it's a sticker placed on the floor. So we can keep the height number on 0. After we've applied the calibration, we can also go back to offsets and go to verifier, and here we can see at which point the camera is aiming. So right now we are looking at the origin, and the Mo-sys system knows that we're looking. As you can see, as I move the camera, it changes the numbers depending on where are we aiming. So now, when we're looking at the origin, it tells us 0, 0, which it knows where the origin point is located. It is good. Now we can also do the same test and look at the x-axis point. Looking at our x-axis point, you can see it tells us 2.5 meters and 0 in height and y-axis, which is also correct. So that point is also good calibrated. Now we also look at the third and last point and check if it's also correct values. When we are satisfied, we can go back to main, and now we can set the reference height number. In our case, it's 0 because we're set up everything on the floor, and we can press finish. And now it asks us to save the map on the disk. Yes. Finished saving the map. In the provided kit, you also get a wireless keyboard with a USB dongle and a USB stick to transfer and copy your maps to the USB drive, or to copy them back from the USB to the system. I will connect our wireless keyboard dongle. And now we can use the system with the wireless keyboard. And to make a backup, we go into main and we can go to backup tab. And usually you should be able to detect the USB drive. In our case, it doesn't work, so we can't use the provided options to copy files to the USB drive or back. So there's another way to copy or back up your maps by going General, and here you have a full screen button, which you can disable the full screen mode, and you can go into your USB of the Linux operating system, and in the USB you create a StarTracker folder, and inside that folder create the maps folder where you will backing up your maps from the StarTracker processor. Here under bookmarks you can see the maps folder, which the map files are created and saved. You want to select those two files and right click, and you want to copy them. You want to go back to your USB drive under your StarTracker maps folder, and you want to paste them. And now you're ready to go back to the StarTracker, and you can turn on full screen mode, and you have made a backup of your map. And optical good, our map is good, we have the stars, and now we are ready to move on to the next stage, which is connecting the Mo-sys StarTracker to our computer and getting started with Unreal Engine. Okay, so before we jumping into Unreal, we have changed our lens to a prime lens that we're going to use, and now we're going to mount our manual focus system and the provided lens decoder in the Mo-sys system kit. In the kit we get two gears, one for the focus and one for the zoom. But in this case, because we're only going to use focus abilities, we can detach and put on the side one of the cables and use only one gear. I will be mounting it one of the rails. I want to align it with the gears, and I will tighten it. The gear also has like a spring load, but we want to have it tight on the teeth. We can check it spins, so we can move on to connecting the cable. Because we're using a prime lens with only focus capabilities and not zoom, we're going to connect the lens decoder into the focus input. And we also have for zoom, the digi input is for more modern digital zoom lenses like a Fujinon and Canon. So that's ready. We will continue mounting our manual follow focus. We check that it spins. So now after we have mounted our focus system, we will go back to the software. We will unlock the menus. We will go to offsets. We will go to lens. And here we can see focus percentage. And we want to rotate our follow focus and go from one end, so it knows where it's 100% of full focus, and go to the other end, so the system knows what is 0. You can do it a couple of times back and forth, so it knows what is 100, what is one end, and what is the other end. So we know it is working. So now when we're done with the focus system, we will continue connecting the Ethernet cable and the SDI to our computer setup. So now I'm connecting the Ethernet cable to the Ethernet port of the Mo-sys processor. And we have a setup where the Ethernet cable goes into a router, which is also connected to the same network, which is also connected to the PC we're using. And now I'm also going to connect the SDI to the camera itself, so we get also video to the PC. So we've connected the system using an Ethernet cable, but you can also use the provided Wi-Fi antenna and connect it that way to Unreal. To check if we're connected to the same network, we can go to Data, and here we can go to My IP, and we can see a status connected. And this is also the current IP of the Mo-sys processor unit. You want to write this down it will be necessary to put in later in Unreal. Now we can move on to Unreal. So now we're at the PC, and we're going to start off by setting up Unreal. You want to have the latest Unreal Engine software installed, and we're going to download also the latest Mo-sys software plugin. So here we have already the latest 5.2 Unreal software installed. We're going to go to Mo-sys, to support Mo-sys.com website, and here we can find the manuals, downloads, and some videos. At the Downloads tab, we can also see the latest Mo-sys VP Pro plugin. So we have tried not the latest update of the plugin VP Pro, but we've worked with the version of 5.2. Newer version of 5.2.01 came out, but it has some bugs, so it's sometimes better to work with the more previous versions that might have less bugs. So you're going to have to test out for yourself which plugin works better depending on your software version with Unreal. So we will continue with the version 5.2, which is more stable. And first we're going to start off by making a new Unreal project. We're going to make a default film video blank project. We can just call it a test project. We don't need ray tracing. We can have starter content, and we can create. So after the project is created, we will go to the directory where the project is saved, which is in Documents. We have it here under Unreal Projects, and here's the test project 2 we created. In this folder, we want to create a new folder called Plugins. In this folder, we want to copy the VP Pro plugin that we just downloaded. We're going to need the compositor and the Mo-sys VP Pro folders. Switchboard is necessary if you have a switchboard. In our case, we don't need that. We're going to copy the compositor and Mo-sys VP Pro folders, and we're going to paste them here in our project folder. We could also copy the plugin directly into the Unreal Engine directory, but sometimes you want to have different settings depending on your project, so it's better actually to copy them directly inside the project, so have the plugin in separate projects. So we can close this. After copying the VP Pro plugin into our project directory, we're going to restart the project, and we can see that our plugin was enabled. Otherwise, if it's not enabled, you want to go to Edit, Plugins, and you want to enable Mo-sys plugin, VP Pro, and you want to restart Unreal. Now, because we're using Mo-sys VP and not the free version, we need to put in our credentials and log in. We also want to enable all missing project settings and plugins. We want to restart Unreal. Also, we want to check if we have all the necessary plugins like Live Link, which is checked, Mo-sys VP Pro, which is also checked. If you don't have any of the Mo-sys plugin windows, you can always go here to Window, and under Mo-sys panel, you can open and place them in your project. We want to have the video controller. We want to have the status window, which we already have. Camera monitor, we also have it here at the bottom. We want to have a take log. We can put it here next to the camera monitor window. We want to have lens tweaker, which will be setting up the lens file and tweaking the settings. But that's for the next stage. Focal distance wizard, we can also have it open next to the lens tweaker. We want to go into content drawer. Under plugins, here we can see Mo-sys VP Pro content. If you don't see this, you can go into the settings tab here in your content browser, and you want to check show plugin content. After it's checked and you can find the Mo-sys VP Pro content, we can go into the starter content folder. And here we have maps, and here we have different example levels that we can start to work with. We will start by opening Mo-sys VFX example. Now when we have the Mo-sys VFX example level open, we also need the StarTracker window, and we also want to have the Live Link tab. It's really good if we have them all placed in one row under your viewport. So another thing what's also important besides having the hardware side of things set up, also for the software. Obviously we want to have the newest Windows, we want to have the latest NVIDIA drivers or your graphic drivers. What's also important in having a tight VNC to access the StarTracker, and you want to have the necessary drivers depending on what capture card you're using. So tight VNC, and all this can be found under manuals on support Mo-sys website. Now back to Unreal. Under Live Link, we will add a source. We have Mo-sys hardware source, and we will add a UDP mode. And here's our computer. We can look for StarTracker, and here under subject name, we will name our camera. We can call it ACAM, and we're going to add the new subject. Now when we have the ACAM, we want to save it as preset, because otherwise we were going to have to do this process under Live Link every time when we start a new project or we open the same project. So we want to save the preset. We can call it again ACAM. Now we can see it's saved in our content browser. Now when we have ACAM, we can go StarTracker, and this is the IP address from the StarTracker when we look in the monitor from the StarTracker. And under Live Link, we can choose our ACAM. Here, under Lens, you can have it blank, but you will be adding your lens file, which you can get from the Mo-sys website. Depending on what lens you're using, you need the necessary lens file to get the focus and the zoom capabilities for doing also the later lens tweaking. Now, when we have the ACAM, we're using a 24mm prime, and now we can do auto configure, and we can confirm, and we can press restart and confirm again. After enabling the necessary plugins, we want to go to edit, and under project settings, we want to go to Mo-sys VP Pro. We can change different modes depending on what kind of setup you have going on. Are you doing like production or broadcast or for post-production? In our case, we can choose VFX, or you can also choose AR, but we are going to choose VFX. And also under format, we want to have same frame rate that matches the project, and also that it matches your camera that is filming. Across all of the systems, you want to have matching settings. You want to have the same frame rate. In our case, we have 24 FPS. After restart, we can see it always opens the test project too, but we can also go back to project settings. We can go to maps and modes, and we can change what level it opens. We can check VFX example. In this case, it will open Mo-sys VFX example map every time we restart. But now we can go into our content browser and go back to plugin folder, starter content, maps, and we're going to start the Mo-sys VFX example level. Under video controller tab, we can open the player. Under video controller, we have a configure button where we need to configure the SDI input. In our case, we have a Blackmagic video card, the deck link, and the first input, we're getting it from our camera. In our 4, we're getting the output towards our monitor. And you want to also check that you also have the same output format in the same frame rate as your project and your camera. And we're going to choose the input, which is number 1 for our case, and you can press refresh that you can see that you're synced and you're getting a video feed. After restart, sometimes you can see under Live Link we have lost our ACAM, but because we've saved it as a preset, we can open it up again and we can select Mo-sys UDP source, and here under tracking is the network interface IP address. Here you want to input your PC's IP address, not your IP address from your camera or from the Mo-sys system. To get your PC's IP address, we can go in your command prompt and you can write in ipconfig, and here under IPv4 address we can get our IP of our PC. When you input the number, you also want to make sure that you press enter so it's confirmed. Here under ACAM, you want to make sure the port number 8001 is the same port number as in your Mo-sys system. You can also go under StarTracker, and here under StarTracker, you want to have the right IP address of your Mo-sys. Usually, it automatically detects the IP address of the Mo-sys if it's connected to the same network. Otherwise, you need to input it manually. Here, for under Live Link, we're going to choose ACAM, and we're going to auto-configure and confirm. And here we have the VNC button. When we press it, it will open up VNC, which you need to install to get access to Mo-sys StarTracker. And from here, we can also use the different tabs and change settings, see our offsets, lenses, and data. We can also right mouse click to lock the different menus. If they're locked, right mouse click to unlock them. And you can also lock menus, and you can also lock buttons. To unlock buttons, you need to first not just unlock the menu, but you need to unlock with right click onto the button. So we will go under data, and we want to make sure this first IP matches to our PC IP address that we've put in under Live Link. The port is the same, and here we want to enable the connection by pressing on. And here we're seeing that we have a UDP connection between the Mo-sys and our PC. Status is connected. So we can minimize VNC. Back under Unreal, we can see we're getting tracking data and we're synced. Right now, we're not getting any video. To get video input, we want to go under Window, and under Viewports, we want to open Mo-sys output. And we can place it around, or we can have it on another monitor. It seems small, but when you refresh it under Video Controller, now we can see that we're getting input from the camera. We can also see under the Mo-sys status, tracking data is green, video is green, and sync. So everything works as it should. Just lens distortion is yellow, which tells us the lens distortion is not checked under Mo-sys camera actor. But right now, we don't need it because we'll be doing more lens tweaking later on. You can always go under status and mouse hover to get more information about the different status points. We need another necessary actor in our scene. Under actors, we will go under Mo-sys. We will put in a composite mesh. We're going to place the composite mesh roughly close to our Mo-sys camera. This virtual red camera is actually the representation of the real camera in our studio. After placing the composite mesh, we have the output window open. We also need to open the Mo-sys keyer, which is under Window tab. After opening the Mo-sys keyer, you might have it that it's already keying if this is checked. If unchecked, it's not doing the real-time key. And you can also press to select the background color, and you want to play around with the background threshold. It might be placed at 0, and when you do the key, you might have it grayed. In our case, it works when we put it on 500. You can see that it is doing the keying. And now I'm going to go into the studio to also check the camera output. We can also move the camera so we can see the tracking works, but there's some delay between the Mo-sys and the camera feed itself. So we can fix that delay inside Mo-sys right now. After some movement, panning left and right, we can see the Mo-sys has adjusted its delay, and now it matches with the camera. If there's more delay, you can go under Tuning tab, under Delays. Here you have some options that you can input delays depending on if the Mo-sys camera itself is going behind the camera. We can input delays for pan, tilt, and rotation. And it works by putting in increments by 0.5. And if a number of 2 is equals to 1 frame. In our case, we are not having any delays because we had a low error margin. So we're going to keep it at 0. Usually, can play around with inputting 2 or 4. Now we're back in Unreal. We can minimize the keyer, and we can go under Camera Monitor, which you can also get it from the Window Mo-sys panels. Under Camera Monitor, we will be inputting the camera's IP address. As you can see, it's set as ARRI camera, but you can change this under going Edit, Project Settings, going down all the way. Under Mo-sys VP, On Set VFX tab, Under VFX tab, we can see camera model, and we will change it to red. We can close it down, and here we can put in the camera's IP address. And you want to have your camera connected to the same network as your PC and Mo-sys. And now we can see it's getting a connection. We're seeing the timecode from the camera itself. And we would also like to match the timecode to the Mo-sys and Unreal timecode. And we can do it with the next step. After we've got the connection with the camera, we got the timecode, but we also want to have the timecode matching to Mo-sys and Unreal. We can get the timecode provider by writing in timecode under Window, and we can get timecode provider from Unreal, but the timecode is default from the system. We can get Genlock writing under Window tab, and the Genlock is also 24 FPS that is matching to our project and camera settings. To match the timecode provider to our camera, we're going to have to create a new blueprint. We can go under Content Browser, and we can just under Content, we can right-click, create a new blueprint class. Under all classes, we will write Blackmagic, and here under Blackmagic timecode provider, not the custom time step. This is for Genlock. But under Blackmagic timecode provider, we select and we create. We can rename it BP Blackmagic timecode. We will double click and open it. And here on the Details tab, under Timecode Format, we can uncheck Auto, and we're going to choose our input from our camera, from the Decklink 1. Choose Full HD, and we need the matching FPS. We can have the format as LTC. We press Apply, compile, and save. We can close that. Now we're going to have to go under Edit and Project Settings. We can write under Search timecode, and here under timecode provider, right now it's none, and that's why it's just taking the default timecode, which is the time of the PC. Here under timecode provider, we can see that we have the new blueprint, BP Blackmagic timecode. When we check that, we see it refreshes. We can also press here to reinitialize. If it doesn't work, select none and select the BP again. And now when we choose that, and it matches to our camera timecode. If you don't automatically get this, sometimes you're going to have to go back to your content browser and open your blueprint and check that this is matching to your camera and your project, and you want to apply. Compile and save. And you can go back, choose none, and you want to jump back to your blueprint. Now you're all set with your timecode. So let's move on to the next step. Okay, after we have set up the timecode, we're ready to move on to the lens tweaking process. But first of all, we want to make sure we are in the right Mo-sys VP plugin mode. We can make sure going under Edit Project Settings, you go down to Mo-sys VP and make sure you are in AR mode. After that, you want to make sure you have a live link connection to the StarTracker, and now we're going to move to the Lens Tweaker tab. If you can't find it, you can always open it up under Window, under Mo-sys Lens Tweaker. Here, it wants you to open the Lens Tweaker level to start the process. So first, you want to save, and we're going to load the level. After we have loaded the level, sometimes you need to connect again the live link, and you can do so by going under your preset. You're going to have to input your camera IP again. Every time you change levels, you're going to have to do that. That's all good. Now we can move on to the Lens Tweaker tab. If you can't find it, you can always go here under Window, under Mo-sys Lens Tweaker. To start with the process, you're going to have to use it under Play in Editor. You want to press Play. After we have set up the live link with the StarTracker under Trackers, our tracking solution should come up. Otherwise, just refresh on the button and wait a few seconds. Select the tracker and select the lens file in your library. Here are all the lens files connected to your account. You can purchase more lens files on lens.mo-sys.com. Now you want to have selected your tracker, your lens files in your library, and then select the lens history file. In our case, this is our base file. that we have for this example. It is not the actual lens file that matches to our lens, but this will do good for our example testing. And now you want to input lens serial number and camera serial number. You cannot have this empty. So in our case, we're just going to put random numbers. The short description will become the display name for the selected lens file when saved. And comments you can leave empty. Now we can move on to the Scene Setup tab. Now you don't have to press anything anymore. Here you have more file details, but now we can move on to the Scene Setup tab, where we'll be using a pole as graphical type for matching the lens distortion with the real world distortion, by matching it with the C-stand that we have set up in our scene right now. But first of all, let's move to the camera. To continue with the lens tweaking, first we want to level the camera. You don't want to just have the tripod level, but you also important to have the actual camera level. Use a water level. We want to have the tilt level and also roll, because for this setup we're only going to be using panning. In our studio, you want to take two poles. We're using two C-stands, and you want to have one in your far end of your studio. More, if you can have it more than 6 meters. We have it on a distance of 8 meters, and the near pole is going to be somewhere between 1.5 and 3 meters. We have it on 2 meters distance from the camera sensor. And it was also important, you don't want to have them aligned. You want to keep a distance like space between them. Also, you want to put your camera lens iris somewhere between f16 and f22. That's like a recommended value for this process. And also, in Mo-sys StarTracker, here under focus, as we change focus, the percentage can change. If you don't have this set up, you can reset the values by holding 0 lens button on the StarTracker processor here. We're going to hold it a couple of seconds. Now we can see on the StarTracker monitor that now it's 0. Now we have to manually focus from one end, so it knows which is one end, 100%, and then manually focus to the other end, so he knows what's 0. And you can do it a couple of times back and forth. Also, for the next process, it's recommended that you have a laser distance measure, so you can measure the distances from your C-stands. And in our case, we have a distance for the far object 8 meters, and to the close object is 2 meters. And also, in this process, you want to have a crosshair in your camera monitor, and you want to match the crosshair to the far pole. That crosshair, you want to place a marker that is visible every time when you pan the camera, and you also want to pan your camera to the close pole, and you want to place a marker, and the markers need to be visible every time you're panning the camera. And now you want to place the camera crosshair centered with the C-stand marker. And now we can move on to the Unreal side of things. And under Scene Setup, we have a couple of different options. We have graphics that we're going to use. We're going to use 2 poles to match to our 2 C-stands in our studio. Now under pole, we can use the distance or coordinates, but we're going to use distance, and we're going to put the distance of pole that we have measured before. It was 835 centimeters, and you need to input in centimeters. And here's the first graphical pole. You can always press Identify Graphics to see them. And with the crosshair button, it's going to be placed and matching with the camera's crosshair. And now, because before we have matched the red tape on the C-stand with our crosshair, now when we match the graphics, it matches the crosshair to the marker on the C-stand. You can always toggle visibility on and off. With this button, you can now move with the mouse click around your screen where you want to place the graphics. But it's easiest just to match it to your crosshair, which is in middle. And to see the graphics 2 pole, you can just press for the middle, and now they're both in the middle, but we can move the one by clicking and match it to the second nearest C-stand. And we also want to change the distance to 200 centimeters. What is also a good tip, you want to have the virtual graphics a little bit on the edge of your C-stands. You don't want to be covering the C-stand, so it's going to be easier to do the process. So you want to have them on the left edge of the C-stands, which is recommended. After we have done the scene setup with the graphical poles, we can see 1 and 2. We can continue to the Tweak tab. On the Tweak tab, we have a couple of options. We will go to the global zoom tweak, and we're going to use the global zoom tweak method because we're using a prime lens. We're not going to cover zoom lenses in this tutorial. We're only going to cover focus. And here you can toggle to open the zoom 0, so you can adjust the positions of the graphics poles so you can match them to the real poles. You want to point the camera to the center of the far object. You can also use the CX add and CY add to change the position of the crosshair, as you can see. But in our case, because we have already matched it to our crosshair, we don't have to adjust the C and Y X add. And now you want to pan the camera so the far object is on the right edge of the image. After you've panned the camera to the left and the far object is on your right side of the frame, you want to use Scale FX to match the virtual pole to your real pole. As mentioned before, you don't want to have it on top of each other, but just on the edge. Now you want to pan the camera that your near object is on the right edge of your frame. Now you want to use EPD add, which stands for entrance pupil distance, and you want to match the virtual to your real pole. And I'm just trying to match the edge, not the actual in middle of the pole. When you have changed EPD, you want to make sure that the middle virtual pole is matching to the real one. If it doesn't, just repeat the steps, moving the camera so the middle pole is on your far right, and try to match it with Scale FX. Now we're going to move on to the Edit Focal Distance button. And the Focal Distance panel allows the user to edit or recreate the focal distance table for the selected lens file. And we're going to use meters. And you can start the process by pressing Start Focal Distance Wizard. By pressing here, it's going to move on to the Focal Distance tab, which can also be found under Window and Mo-sys here. Here you can see the steps which you need to do, and you can follow along. Otherwise, you can do it here, or you can also do it directly under the Lens Tweaker tab in here. It's going to be the focus percentage that is connected to the StarTracker. Right now it's 100%, and you can change it manually. We want to have it automatically matching to the StarTracker, and we can do it by checking the Use Current Focus. And here we can change the distance. First, we want to add 100% focus with an infinity. That should be the number 1, and we can add that. And now we're going to move on to manually focusing and putting in distances, and you want to have somewhere between 6 or 8 points. And for this process, we're going to move to the studio. It's good to have an assistant while a person is working in the VP Pro part. And you want to take a black board, which you can focus on, and place it furthest in the middle from your camera. You want to measure the distance with the laser pointer from the camera sensor, and you want to focus the camera on that board. And then you want to input the distance here and press Add button to input the value. And then you want to move the board closer to the camera, 1-2 steps, and you want to focus on the board again, and the focus percentage will change. You want to measure the distance again, and then input it here and add the button, and you want to keep on until you get as close as possible to 0%. You don't have to be actually on 0%, but as close as you can. We've done the focal distance wizard, and now we're going to save the values. And it's going to tell us in the log focal distance has successfully been updated. Another tip you can do while doing the focal distance measuring, you can go under Scene Setup, and you can disable the visibility of your poles, so you have a better visibility for doing the process. You want to have the poles visible again. you want to go under tweak and under advanced tweak. Here we have our sample position and sample proximity information, which will appear in the lens data panel above. When the proximity value is 1 or 0, this means we're spot on at the sample point. They're always divided into 6 parts. So it doesn't matter how many points we have measured, it will always divide these in 6 parts. And now we want to go and we're going to do tweaks for each part. First we want to focus until we get 6 out of 6, and we want to be close to 0 or 1, and then we're going to continue doing the edit on the tweak. Now we have set up the focus close to 100%, we have our proximity 6 out of 6, and we're close to 1. Now assuming your virtual graphics and real-world object line up in center of your screen, we can pan the camera left so the far object is on the right edge of your screen. It's good to have an assistant at this point. You want to pan the camera to the left so your far object is on the right edge of the screen. And now you want to press edit button, and you want to use FX virtual to align the virtual graphic with the calibration object. At this point, your graphic 1 and real world object should match up at the center of the screen and the right edge. Now you want to pan right so the far object is on the left edge of the screen. If your graphics 1 matches to your real world object, pan the camera so the near object is in the center. Otherwise, if the graphics 1 does not match the pole, you need to change the principal point CX and principal point CY to align the virtual graphic with the far object. So we want to play around with CX and CY. Pan the camera so the far object is on the right side. And now we're going to adjust FX virtual to match it. Now pan the camera to the other side. Now pan it to the middle. Okay. Pan the camera to the right. Now be looking straight ahead towards the far end object. The virtual line matches to the real world object, and to match to the near object, you can play with the EPD and the K1. With the K2, you can also adjust the lens distortion so it matches the lens distortion of the real world pole. Pan the camera so the far object is halfway between the center of the screen and the right edge. So you want to have it right here somewhere. So we can see it's matching. If it wouldn't be matching, you can play with the K1 rating to align it. Now this part is done. We can press store to store the tweak on this percentage. And now we're going to change the focus so we get to 5 out of 6. Aim back to the center. Okay, now we're going to move down to 80%. We want to be 5 out of 6, and we want to get our sample point close to 0 or 1. We know we're close to spot on. And we're going to go and press edit button and repeat the last steps as we did before. We want to continue doing that for all the focus samples and store them. When we're done with that, we can press on save. After we have saved, we can go to Lens Files tab, and now we can store our file in our library. And we can see in our log it tells us successfully saved. And we can also see this is our newest file. And by pressing deploy to IP, this file, which is now created and selected, we can send it to our Mo-sys StarTracker. And it tells us that the file has been successfully sent to the StarTracker. We can open up VNC. We can go to Data. Under Lens Data tab, we want to enable our lens file. And we also want to choose our lens file by pressing Load File. And we have different tests we've done before. And you want to choose by inputting the number and just pressing OK. We've loaded that lens file. it is enabled, and we can continue with experimenting with the lens focus system. We can now stop the play because we have done the lens tweaking. So we can now move to another level and test out the lens. So here we are at the end. After we've put on the stars, we've calibrated the Mo-sys system, we've done the lens tweaking, we've connected everything, and I have prepared a sample level here where we can also test out everything that we have prepared so far and our lens file. Right now we can see I'm focused at the plant, and as I'm manually changing focus, I'm changing focus to the virtual camera. And as we can also see, as we move the camera, it moves the virtual camera. Racking focus works, and we can also check that panning and tilting the camera also tilts and pans to the virtual camera. After we have tested out the pan and tilt, we can also remove the camera from the tripod. It's handy to have an assistant to hold the cables for you. And we can now see, as we move the camera, I'm very satisfied with the result.
Cool.
Now back in Unreal, we can also take recordings by simply going Window and opening up the Take Recorder in Unreal Engine. We will also get the sequencer window. Under Take Recorder, Mo-sys camera should come up. If it doesn't come up, you can just simply press the M Mo-sys button to reset the Take Recorder settings. You can also press on the camera to get access to different camera settings, and you can also press on the gear button to get to general settings for the Take Recorder. When you're ready and set, you can just press the record button to take a recording, and the sequencer will start recording. And you also want to start recording on your camera. By pressing the record button, this will also trigger hardware recorders. And when we press record, as you can see, it starts recording. We're panning the camera, and we're going to stop the recording. The recorded files are saved in content under takes and our date. And here we have the recordings. We can also change the names. You want to have the Mo-sys output to be able to see and play back the recordings. To export the Mo-sys tracking data, you want to go to Take Log, which can also be found under Window, Take Log. And here you want to refresh the button, and here we can see our scenes, which we can open, locate, and export, or you can just export them all. These files will be exported as FBX, and they represent the tracking data of the camera, where you can import and nuke and continue with your compositing and post-production. Thank you for listening, thank you for watching, and if you have more questions, you can always go to supportmosys.com, and that's about it. Thank you. Bye.